Now let's work a problem to find the work done by a gas in expanding from a state that has, let's say, a pressure of 200 kilopascals, which is about 2 atmospheres, down to 100 kilopascals. And it goes from having a volume of, let's say, 2 cubic meters up to 6 cubic meters. All right. Now let's take it in 3 different processes. We'll do the process in blue, which starts at the high pressure, expands, and then drops down. We'll do a process in red, which drops down and then goes over. And we'll do a process in green, which just follows along the diagonal. So for the blue, the work is the area under the curve, P delta V. So it's the high pressure times the change in volume. That's going to be 200 kilopascals times 6 minus 2 is 4 meters cubed. It turns out a Pascal meter cubed is a joule, so this is simply 800 kilojoules of energy. 800 kilojoules of work done. For the red path, I only consider the area down here. So there, the work is equal to still pressure delta V, but now it's the smaller pressure of 100 kilopascals times 4 meters cubed. So that's a work of only 400 kilojoules. If I take the green path, well, then I need to worry about this green triangle and this area under here. I already know the area on the bottom. That was from the red path. For the green triangle, I get a work equal to 1/2. The change in pressure is the height of my triangle. It's 100 kilopascals. The width is 400 or 4 meters cubed. And then I add on the 400 kilojoules I have because of the red square underneath, red rectangle underneath. And that gives me, this becomes 200 kilojoules plus 400. I get a total of 600 kilojoules. Three different paths, 3 different amounts of work done. The change in internal energy has to be the same. So having different works means we have to have different amounts of heat in each case. One comment, I could imagine coming out along the top path, doing a lot of work with high pressure, then dropping to a lower pressure, and recompressing my system. In this way, I get more work done by the system than I have to do on it, compressing it. If I compress here on the red line, I have to do a negative 400 kilojoules of work on the system. But if I expand on the blue line, I get a positive 800 kilojoules of work expanding. So I'm actually getting more work out than I put into it. Where does that energy come from? It comes from the heat. But this is the idea of an engine. I let the gas do more work on the system than I do back on the gas to get back to my original position.